Creating velocity volumes is easy in Insight. Just take a look at some of our suggested workflows and videos posted on our help pages. Matching a velocity to tie the well location can be more troublesome. This workflow uses a delta function to scale the isotropic velocity model to a vertical velocity, in this case derived from well checkshots or VSPs. Here we have an R-blind through a 3D survey linking 5 wells that are all displaying gamma ray logs. Horizons have been interpreted for key structural boundaries and can be used to constrain our calculations. The seismic volume has associated isotropic migration interval velocity data that can be displayed along with checkshots that have been corrected to tie the seismic. It is quite clear that although the seismic velocity is similar to the well velocity, there are differences between the two as expected. The checkshot calibration was performed using the synthetics tool, as can be seen here. The VP log is calculated from the sonic and displayed alongside the checkshots. The checkshots have previously been adjusted and are now showing a good well to seismic tie. Synthetics must be calculated for each well, generating long and reliable checkshot velocity up to the shallow section of the well. The VNMO velocity should be selected as the active time-depth conversion velocity using Configure Time-Depth Conversion from the Control Panel File menu. The VNMO interval velocity is already active here and can be extracted along the wellbore and displayed alongside the checkshots and VP logs. Here, the extracted velocity is seen as the bright orange curve. The delta curve can be calculated from differences between the velocity and checkshot curves, using Svansken's formula linking the ratio of VO and VNMO to delta using the equation seen here. Note that all variables in the delta equation assume interval properties in time. A raw delta curve is sampled using the value in the display sample interval. This is default to 20 meters, which is a typical sample size for a velocity volume. A smoothing window can be applied. The delta curve can be smoothed to individual requirements to address different objectives. Here I am increasing the smooth window from 12 meters to 48 meters to obtain a smoother delta curve. The delta curve is calculated for all wells, and similarities can be compared using section and correlation views. Here the correlation view can be used to display the checkshots as interval velocity. A velocity trace can be extracted along the wellbore and displayed on the same track. A difference curve can be used to highlight the decreased differences in velocity in red. And another difference curve can be used to highlight the increased differences in velocity in blue. These delta curves look ready for input into the 3D delta model and velocity correction. Look in the Doug Learning section of the online help for part 2 of this workflow. If you have questions or would like to discover more, then visit our website at www.doug.com. And remember, have fun with Insight.